Welcome to solverfy.
Now to get the amount of decay per second, for this question we are given in terms of curies. Right, so we need to know that 1 curie is equivalent to 3.7 times 10 to the power of 10 becquerels, where becquerels is defined as decays per second. Right, and so when we have 0.1 microcurie, this will be equivalent to taking 0.1 times 10 to the power minus 6 times 3.7 times 10 to the power of 10, which is equals to 3700 decays per second. Right, so this is the number of decays per second. Now to estimate the dose in terms of serviettes, now we know that for serviettes it is equals to the dose multiplied by the RBE. But in our case we are talking about beta particles, which we're going to assume the beta particles have an RBE of about 1. So now we can actually equate those to serviettes in terms of grays, right? So those is grays for this particular case. Now assuming that the activity is constant throughout the year, right? So that is the number of decays per second is constant throughout the year. We can find what is the total amount, total number of decays in a year. That is 3700 multiplied by this number of seconds in a day multiplied by number of days in a year. Right. Sorry, this number of seconds in an hour. So we have to still multiply that by 24, right? 24 hours a day, then 365 days a year. This is the number of decays in a year. The total energy that is being produced by all these decays, we are given that each of the beta particle has 1.4 MeV. So we take the total amount of decay multiplied by 1.4 MeV. Right, so this is actually 1.17 times 10 to the power 11. Now we got to convert this MeV to joules, right, to get in terms of gray, right, because gray is joules per kilogram. So we got to convert that into joules by using the conversion factor, 1.6 times 10 to the power minus 13. Should get a value of 0.02613 joules. Right. Next, to get our dose, we take the energy divided by the mass of our person, which we are told to assume to be 65 kilograms. So we get a dose of about 4.02 times 10 to the power minus 4 grays. And therefore, our dose in terms of serviettes is also 4.02 times 10 to the power minus 4 serviettes, since beta particles are assumed to have RB of 1. Now comparing it with the background rate, the background rate we are given is 3.6 millisieverts. Right, so we divide this by 3.6 millisieverts, so there's 10 to the power minus 3 sieverts in a year. Multiply that by 100%, and we see that actually takes up about 11% of our background rate, which is not the most significant portion, but it is kind of a significant amount compared to the background.